It's live. Things are going on. Let's see if she's up. People are showing up. Hey, Michael. Hey, Sean.
How you guys doing?
Good.
Hello.
Hello. How's it going?
Hey, how are you?
Good. We're going to give everybody a couple more seconds or so to get in, and we'll call on folks as they come in, so mute your mics. This should be a full house tonight. This is good. Good. Alright, let's see. Another person came in. There's two of him.
Double Harry.
Uh-oh.
Your twin is here, Harry.
Oh dear.
Harry, he's very still.
Yeah, that's a glitch is what that is. Can you boot the other one?
No, he's gonna stick around.
Okay.
Fall out by himself eventually.
Nope. There he goes.
All right, we're gonna start. You wanna?
Hey, hello everybody. Welcome to a fantastic Google Hangout show and tell. As people trickle in, we'll also call on them. But basically, you know, we have like 5 minutes apiece to show off your awesome project for the day. If you're not showing off something awesome at this time, mute your mic, because otherwise we get bad feedback issues and we'll have to mute you, and it's kind of a pain in the ass. So just mute your mic now so we don't have to. We'll call on you in the order in which you appear in our little thingy in the bottom.
Okay, first up, Sean Bonner. Unmute your mic, Sean. And
Hi.
hello, how's it going? Show us your project.
Hey, how's it going? Okay, so I just wanted to show off. We have the, there we go, the 3D printout mock-up prototype of Bunny's Geiger counter that he designed for us for Safecast. So this is the kind of the update version of this other big giant clunky one that was designed in like the 80s sometime. So this takes into account all of the feedback that we had using these old devices. So it has some outputs on the side. It's got a little mini USB, which is both in and out, and then also a stereo headset port, which works in and out as well. So you can plug it into a feature phone and use that as an analog modem if you needed to. It's got an OLED screen and a bunch of reprogrammable buttons, and then it uses the 2-inch pancake sensor, so it's sensitive to alpha, beta, and gamma. And yeah, we're pretty excited about that. So hopefully we'll have some versions of that available soon.
Okay, I have some questions. Where this is Phil off the side. I'm going to just be a hand talking.
Hi.
Where did you get the case 3D printed from?
So we're not making it ourselves. Medcom is making it, and I'm not sure where they did it, but I think it was someplace that Bunny sent them to.
And what do you think the cost, just like bill of materials cost on making one of these is going to be?
Well, the sensor itself, just the 2-inch sensor, is going to, that piece alone costs $100. So, you know, I think that just materials costs on this is probably a little over $200. Obviously, if you know, it's completely open source and everything, so you could take and leave whatever pieces that you wanted and change the cost on it. I think the retail price that Medcom is going to sell the version that they're producing is probably going to be about $800. We're going to do a special Kickstarter that's sort of just a thanks to Kickstarter because they helped launch Safecast in the beginning. That's going to be clear like this with the clear plastic, and it'll be numbered and everything. And that one's going to be like $400 with some of the money going to help Safecast as well. So.
Gotcha. And for the folks who don't know what Safecast is, can you just describe it briefly?
Oh, sure. We started right after the earthquake last year, 3/11 earthquake, and have been crowdsourcing radiation measurements. And we have about 3 million data points that we've collected and published now that are completely open and free for anyone to use for any purpose. So it's the largest data set that's available.
Fantastic. And can you hold up the device one more time, front and back?
Yeah. So that's the front.
Or is it not?
No, it's not functioning. This is kind of just.
Prototype.
Yeah. There's another version that's just being for software, but it's not in a case or whatever. It's just a screen and a board and other stuff. So that's the front, and that's the back.
And what were the changes that you requested from the off-the-shelf one? What is it that's different?
Oh, well, the thing is that Geiger, there's not really an active market designing and refining Geiger counters. So the last time any revisions were made to like general Geiger counter designs was in the 80s. So that's what this was. And so 20 plus years later, there's more that we can do. And so just having a screen that only shows numbers. Having an OLED screen gives us a lot more options to do things. Having USB in and out does a lot more things. A different form factor that you could put this in your pocket. You're not really going to walk around with this in your pocket every day. So just reprogrammable buttons, so you could change everything. I mean, this is the interface on the old one is literally a switch that just slides on or off. So we wanted a lot more functionality and to be able to do more things with it. You can plug another sensor into this as well and record other kinds of data. So it does tons more stuff.
And the previous ones were made before there was internet, so they weren't.
Yeah, exactly.
Published
no connectivity of any kind.
Yeah.
Is there a reason why you didn't put a GPS module in it so it would location stamp your readings?
Battery. The ones that we make that we use, like I have one of them here. This is our sort of our Geiger system that we attach to cars and drive around with. This has GPS in it and wireless and a bunch of other stuff. It's a battery issue. Medcom wanted, and Bunny, they were both, when they were designing it, they were really interested in battery life. This one you can leave on for 2-3 months at a time, and it just works all the time. This one will have a very similar battery life to that. If there was GPS, it would be dead in like a week and a half or something. So.
Very cool. Okay, cool project. Thank you so much.
Okay, great.
All right, next up, Michael, unmute your mic and show us your project or your photos. You went to a flea market, right?
I went to the flea market. I sent you guys a link. I don't know if you want me to just drag URLs to the chat and you guys can bring them up somehow.
We can't do that.
I don't know how that works.
Yeah, I don't think we've ever been able to do that. Maybe you can briefly describe it, and then we'll do a post later so people can check it out. So what did you go see?
Okay. So at the electronic flea market, you find all sorts of stuff. We had, in ham radio, you have what's called the silent key, somebody who's passed. So for the last 2 months, guys have been coming out setting up about 6 cables worth of gear this person had, multiple oscilloscopes, various signal generators. There are guys that always show up with other gear. There's one guy that restores and resells. He has these beautiful, you see the pictures of these 100-year-old microscopes and real Edison recording devices, wax devices, all sorts of various tubes. It's hand tools, both modern Chinese junk and stuff that's come down from generations. We had about 100 sellers, so a full line of people. I got there at 3 o'clock in the morning because I help sell tickets to the vendors for their spots. So, and I haven't gotten any sleep yet.
and where is this located? This
is at the Anza College in Cupertino. I did get one good find. Where did I lose the box? A still probably never been used. Yeah, there I am. Picket slide rule, a 1010 ES trig. The case is, there's no scratches on this leather. I mean, this was a great find at $25.
Oh, nice.
I've got a nice collection of slide rules. I got about 5 20-inch scale ones that I can just about read enough to be able to do some math on them. But the 6 and the 10-inch are getting a little small for these 50-year-old eyes.
Very cool. Well, I'm looking forward to the iPad version of the slide rule, so you can scroll, so you can zoom in and zoom out on your own.
They have the apps, but they're a little wonky.
Yeah. All right. Well, after the chat, we'll grab the link of the photos. If you can make sure you just post a link in.
I did. If you look at the chat right now, you'll see I posted it.
Oh, great. Okay. Well, thank you so much.
And open Google Plus, I posted it to you.
And that'll be payment in full, I think. We traded you an Art of Electronics workbook, didn't we?
Yeah, so I guess you haven't sent it out yet for me, though.
I have to see the pictures. I'm just saying.
I know.
Okay. Well, thank you so much. And email support@adafruit.com, and we'll make sure that we get you your book now, too.
Okay, cool. Talk to you guys later.
All right. Thanks so much. All right. Next up, Lon. Unmute your mic and show us your project.
Hey, I'm working on some lighting for a kiosk. I'm more of a coder than an EE, so my stuff is being built out of off-the-shelf parts. Last week in the chat, someone mentioned the language lingo, and this is actually kiosk written still in Macromedia lingo.
Wow.
Let me show you a picture of the actual kiosk first. Let's see if that comes up. Is that coming up?
Nope, unless the kiosk looks exactly like you.
Ah, how about this?
Oh, there it is.
Oh, there it is.
Excellent.
Okay. So the snow in there is getting us around with a couple meters of the flexible sealed LED RGB strip. And
Oh, nice.
how do I turn off the screenshots? Oh, I can show you a... Uh-oh. We're going to do a little dance here with some computers, but here's the view out the window from that installation while I was working on it.
Oh, wow. Is that a polar bear?
That is in fact a polar bear. This exhibit is in the middle of a tank full of polar bears.
No pressure to get it done, right?
Well, it's fun to have him watching.
If you ever see them covering their nose, you know you're in trouble.
This one about to eat you?
Yep.
Yeah.
Okay, so now I'm going to switch computers and we'll show the software real quick. If I can get this to work. Are we back? So this is a mock-up of the software. You saw the 3 screens at the top. I don't know if we can see anything here.
Oh, there's a polar bear.
And there's polar bear, and then so this big area spreads across those 3 screens, and then this little square down here lives on that lower screen. And as you answer questions and the environment gets warmer and cooler, we're going to slowly change the lighting in the environment with the RGB strip.
Oh, nice. And how are you controlling RGB strip from the computer? What's the thing that's going in between the two? Is it just an Arduino?
Well, it was my original plan, but that makes everyone nervous for an installation to have my sloppy wiring in there. So that's the fun part of what we've ended up doing. Let me show the project box here. So the white thing here is a power supply for a fish tank. And this is a DMX controller. And so we're just using regular DMX signals to control the RGB. And then I found online a nice little parallax-based board that takes serial controls and makes them into DMX signals that we can drive the light strip with.
Oh, cool. That's cool that they don't think that using like Director and Lingo is as risky as an Arduino. That's cool. I like this. I like the risky scales of installations.
Well, this way we're able to get a board that someone made instead of something that I made.
Yeah. No, that's awesome. Well, very cool. When the installation was all done, can you send us a link to it? Because that would be
certainly will. Actually, it's up now. It's open. We're putting in new stuff this weekend, so the lighting should be in sometime next week.
Oh, great. Well, that's cool. We'll cover that on the blog.
All right.
All right. Thank you so much, Lon.
Bye.
All right. Next up, Ray. Hello, Ray. Show us your project.
Hi. Hello. So I just wanted to show a very small project, and this was actually posted on Hackaday a month ago, and I just want to show it here because I think it's a pretty useful small project. So this is a little circuit board that I built. It's called the AAASaber. So it's basically a voltage booster. So it's all based on surface mounts components. And there is a little booster chip in the middle that's based on the microchip MCP 1640 boost converter. So there's an onboard switch here, and then also a voltage selector, so you can choose between 5 volt or 3.3 volt. So I've actually when I designed it, I had I had 2 functionality in mind. So one is so I left some pin headers. So I have these pin headers here, which allows me to plug it directly onto a breadboard. So I can use it as a breadboard power supply. So
Oh, that's clever. That's nice.
yeah, so the pins are spaced exactly to match the breadboard, so you can use it. So I really like this because when I do breadboard projects, I just want some quick power source. I don't want to have to use like a power adapter, and I find this like really convenient because it just uses two AA batteries.
Yeah.
And it bumps it from 2 AA to 5 volt or 3.3. You can select it.
That's clever. Yeah, it's a little portable power supply for.
Right. Yeah. So it's kind of fundamentally it's based on boost converter, which is similar to the Minty boost, the very popular Minty booster. But this just uses a different different chip, and also it's like designed in a different form factor.
Yeah.
So right. So the other purpose is I also have I also put it like a LED on this, so I can use it as a like small LED flashlight. And since this is a voltage booster, so even if the batteries are almost dead, you can still like harvest the energy in the batteries and use it as a flashlight. And this can actually last for quite a long time.
Yeah, like lots of people like to do that with the Jewel Thief type projects where they get
right. So I think this is probably more efficient than the Jewel Thief.
Yeah.
But obviously more complicated. Yeah.
It's cool.
Very cool.
It looks like it would probably fit in the bento also.
Yeah, maybe.
Very cool.
Right. So I do have some write-up about this project that you can find on my website. And
Oh, make sure you post a link too because it's coming in backwards on the screen.
Oh, I see. Oh, crap.
But for the dyslexic folks, they read it perfectly right now. Or if you have better vision.
Yeah. Actually, so does it look like backward on the side?
Post it
Yeah,
up.
it's perfect.
Oh, there you go.
So how about this?
That's
Yeah.
perfect.
Do you have like schematics up so people can?
Yes,
build it
it's
up?
completely open source. I have a schematic and the the PCB design. There's one kind of interesting thing, which is if you use it on like batteries that are almost completely depleted, then it sort of becomes a flashing like flash LED because it can't sustain the power, the current, drawn by the LED, so it starts flashing, and it can last for a long time, and then until it finally, the battery will die, and then you will get nothing from it.
That's a feature. You meant to do that. That's the low battery indicator.
Yeah.
Right. Yeah. Right. So that's it. Yeah.
All
Okay,
right.
cool.
Thanks,
All right,
Ray.
so we still have a few more people, so I'm going to ask Thomas to go next, and then we're going to try to get Harry, and then Ethan, and then Kevin. So everybody has a couple minutes if you can go fast. Thomas?
Wait, Thomas.
Come back, Thomas.
Come back, Thomas.
Yeah, can you guys hear me?
Yeah, show your project. This is full house tonight.
Yeah, so I've been meaning to come on for a while and show this. I'm at the University of Waterloo, living in dorm, and there's this girl that lives above me, and when, in the first few months, she'd like to get, pretty drunk on a random Tuesday night and come visit at about 4 in the morning when I got 8:30 classes. And to wake me up, she would play this game where she'd see how much food she could stack in my mouth. And I don't know if you guys ever woken up choking, but it's not enjoyable, not at all. So what I decided to do was I just got my scholarship check from the university, so I went out to Zeller's and I bought the biggest Nerf gun that I could find, and it runs through a battery, right, through D-cell battery. So I just cracked it open and put a super basic circuit in there that could bypass the trigger system, so it could be shot automatically. And then so I have it sitting propped up on my fridge in the corner of my room, hooked up to an Arduino, and it has a little tinfoil sensor on the door, and it plugs in through USB over serial into my laptop. The idea is that when the door opens, the Arduino knows, it starts talking to the computer and asks the computer, is the system armed? And then my software, whether it's armed or not, it will, give it the go-ahead and it'll start shooting. But since it's hooked up to the computer, I can take advantage of having a webcam. So not only does it, lay waste at the door for about 15 seconds, it also films the whole entire event, records it, and uploads it to the internet. So unfortunately, it's kind of hard to show because I don't really have like a portable webcam.
That's totally
I'd like to just see the video of.
But
the,
I don't know. I don't know if your
roommate
mom told you, but I think she probably just likes you.
This girl might just like you.
She just probably
Yeah.
it's the only way she knows. She's like she knows I'm supposed to feed him.
Yeah.
She doesn't realize she doesn't supposed to do it at 4 in.
Yeah. So I had it all posted on my website.
Maybe
Yeah,
if she likes him, she likes being pelted with
post
her.
up a link and a photo. This is fantastic. This is a great story. I didn't know where you were going at first with it, but I liked the journey we were on. This is a cool project.
That was quite a trip.
Yeah. I have another project that was kind of revolved around dorm security as well. But for the sake of time, maybe I'll talk about that.
Yeah, can you
next week.
can you come back next week?
Yeah, for sure.
Okay, right on.
Yeah, I figured it would be perfect because I'm moving out of residence in a week or something. So, I got to take all this stuff down because it's kind of built into my dorm room.
Yeah, don't leave it there. The next person's not going to be too happy when they walk in.
Yeah, exactly. Do you want me to post it in the Google Plus chat?
Yeah, please do.
Yeah.
All right.
You could also put a link in a comment on the Google Plus page if you.
Okay.
Yeah, I'll do that.
All right, we're going to
Next
keep
up, the girl 2 floors above the cleaning person.
Yeah.
You better watch out because she's going to see it and then she's going to build something that we can use.
All right.
Yeah.
So next up, we're going to try to do
She's like an
3
FPGA expert. I don't know.
3 minutes each. So let's see. Ethan, show us your progress on your project.
Okay, so I got that GPS, your new GPS that you sent me. I finally got it.
Oh, great.
So here it is.
Wow, it's big.
Well,
Ethan,
I just hope. I actually hooked it up and I got the LED to blink successfully, so I know it works. And it outputs data out of what is it, 5 hertz or 10 hertz?
Mhm.
But it was doing it just how you said it would, so it's working right. And then on my, I called the people to order the balloon because they don't have an online checkout service. And I called back yet, so I don't know if I'll be able to launch it, but I'm trying with that. And then on my quadcopter, we got some of the sensors working, like the air pressure sensor, that's working. And also, I actually been having problems with the boost converter I was using. So I found an interesting something that happened. It's see if I can put it up here. Hold on. So it's designed at taking an input voltage of 1.8 volts and up to 5 and output 3.3. But I found that whenever I input a voltage from above 3.3, then it works fine. But if I do anything below, then it'll draw 600 milliamps and short out. And as far as I can tell, the chip isn't blown. And I thought the GPS, I have another one on the back of here. I replaced that because it was causing all the problems. As soon as I turned it on, it would draw too much current. So it turns out the first GPS I had wasn't working right, so I had that replaced. And then I got a new one, and I just soldered it on the board, and it still has the same problem. So does anybody have an idea like what might be going on?
Do you know that it's the GPS? That's when you remove the GPS, does it not have this problem?
It doesn't.
It could be. Well, first off, I see that your inductor is wired on. It's not soldered directly.
That's what was happening. Yeah, that was because the one I had on there, it couldn't withstand the 600 milliamps and burned out. So I was thinking maybe if I put a higher current inductor on there, then it might help.
Yeah, but when you have like 2 or 3 inches of wire between your inductor, that's going to cause a lot of problems. So, because you really need to have it be pretty small. I don't know if that's related, but you should try to find a surface mount inductor that you can fit right on there. Because having long wires, what's happening possibly is that inductor is so close to the GPS that it's sending all this noise right to the GPS is picking it up, and it's saturating, and it's freaking out, and so it draws more current, which causes the inductor to also freak out.
I see.
Back loop because they're so close to each other.
Congratulations on your first GPS jammer project.
Yeah. Because it's a really great way to totally mess up a very sensitive electronics is to put an inductor really close to it.
So one thing I did is I just put 3.3 volts right on my power rails, and it sucked about 120 milliamps. That's because the pick on the front side is running at 80 megahertz, so it sucks a lot of current. But I think maybe I should move to a new chip that isn't as parts dependent. Maybe the microchip one that he used for his battery saver project, or whatever.
I think what you might want to do is to start have the problem is your power supply is just so close to your GPS. It's far from your sensors, but
yeah,
it's just going to be really noisy. So, if it works with higher than 3.3, if you put a lithium polymer on there, that's going to be about 3.3 volts or higher. So you should just go with that. Maybe you don't use a boost converter. Boost converters are very noisy. A linear converter is going to be a lot quieter, and you're going to get better sensor readings and better GPS performance with.
That's what I'm considering now.
Yeah.
Because originally I was going to be able to run this whole thing on a single AA battery for testing purposes, which would be pretty neat and be smaller.
Yeah.
But I think I'm going to have to go to the ultra low dropout.
You might want to do the ultra low dropout. It's always tempting to go with the boost converter, but they are very, very, very finicky, and especially when you have sensitive electronics. And as you saw, you can cause feedback loops. They can be a problem. So, I think if it works in LDO mode, just put 3 batteries or LiPo on it.
Yeah.
And just run it. Keep going. Press the attack on your board. Move on and test the next thing. Don't get hung up too much about the power supply.
Okay. Well, I don't want to take up too much time, so.
Okay. Well, no, this is great, and keep coming back with your progress. You have plenty of time until you get that balloon.
Yeah.
So.
Yeah.
Ethan's our balloon tester. We have this high altitude GPS, and we have to have a person test it. So Ethan's our.
Well, hopefully we do summer.
All right. So we're going to try to get through 2 people in just a couple minutes, Harry, and then Kevin. Do you think you can do some projects in a couple minutes each?
Yep. Okay. So extreme TLDR. You remember this?
Yes.
This was the thing. This is the other new thing, which is about the size of, that display. That is a 0.75 inch by 0.75 inch SPI compatible hardware random number generator. It's
cool.
The same hardware that's built up on here, just made smaller and built up on here. So I actually literally got this board today. I was out at a class, first aid class, and literally got back at 8 o'clock, and here I am with it all soldered up. So that was a bit of rush soldering.
You're doing that diode hack, so that gets to noise, right? Is that how you're?
Yeah. That's a
certified, yes?
It's a not until tomorrow. It's a 2-day class.
Okay.
But anyway, yes, it is a Zener diode, voltage reference, noise is amplified, run into an AT-Tiny. I haven't actually had a chance to test it yet because I wrote up all this code that's not the same as my original code, but pretty similar, but I just haven't had a chance to update it yet. And downloaded and even test it yet because I've just been so busy. But this will just plug into a breadboard and be all set. And the silk screen actually came out really nice. I'm really happy with how Lane did that.
Go random.
Yep, that's the hope. So.
Very cool. Okay, post a link to it when you write it up or put it anywhere, and we'll cover it on the blog.
Sounds good. Thanks.
Thank you so much. All right, Kevin, you have 1 minute.
Okay. No, I'll be real quick. I've been really busy and doing too many things, but we have Ducky Bot Alpha.
That's right. I remember you started this with the giant.
So, we're launching at the Cambridge Science Festival. There's a mini maker fair there, and so we're going to try to get kids to try to bodge things together to make ducks go, and so I'm going to make some little motors and stuff like that for them to go.
Okay.
I finished the command line code for the Adafruit fingerprint reader.
That's right.
And I think you guys posted up my technician at work, and this was an opportunity for me to do an open source project at work, which was really fun.
Yeah.
And he did a really nice job putting it in a box, and I showed that. And I wanted to show you this little thing too. This is really cool. This is just this is a teensy one of your accelerometer breakout boards and a sharp IR distance sensor, all in a nice little box. And we've been using it for an augmented reality project, but now we're actually building that in. So now this one's freed up for just fun projects, and we're going to interface it to Scratch and do some other things like that. So.
Very cool. I like the aesthetic that you have this black box stuff. It's very 2001 Space Odyssey. Tell your designer it's very utilitarian. I like it.
Oh, he's this great guy. He grew up in Soviet Russia, doing tubes and stuff like that, and he's just very handy, and he's really great at doing stuff like this. The other thing I'm doing is I'm working on a bootloader for the Arduino that will load from SD card. I was doing some, the boot drive stuff and stuff like that, and then I found out that this guy about 2 years ago had done something called 2 boots, but I can't get it to work. So I'm basically adapting the SD FAT library code and OptiBoot and sort of mashing them together, and hopefully in the next week or so I'm going to have a bootloader that can bootload from SD cards.
Okay, great. You should share that on next week. We are out of time. We
Okay.
Go.
Thank you so much.
Thank
And
you, everybody.
take some pictures of the ducks in with all the robots. We'll put that up on the blog too.
Cool.
This was a fantastic night. Entirely full house. Thank you, everybody. We'll see you on Ask an Engineer in about 30 seconds.
In 10 seconds.
Zoom.